Welcome to Rani Chemistry classes. In this video, I am going to discuss about the weekend test 9 conducted by Board of Intermediate Education in second year chemistry P block elements, that is halogen compounds. First one is the only type of attraction existing between the molecules of halogens are A. Hydrogen bond, B. Ion dipole attraction, C. Van der Waals forces, D. Covalent bonds. So the answer is Van der Waals forces because these halogens are diatomic molecules, non-polar and symmetrical. They do not form permanent dipoles or hydrogen bonds or ion dipole attractions. Next, second one, which is the strongest oxidizing agent? Fluorine, chlorine, bromine, iodine. So generally, fluorine has high standard reduction potential and high electronegativity, so it can strongly gains electrons. Strongly gains electrons means reduction. If the element undergo reduction, it can act as strong oxidizing agent. So fluorine is the correct one. That is A. Third one, the chemical reactivity of halogens is in the order. So in the case of halogens, fluorine, chlorine, bromine, iodine, from top to bottom, electronegativity decreases and atomic size increases. So chemical reactivity also decreases from top to bottom. So fluorine, chlorine, bromine. Fluorine, chlorine, bromine. So option C is the correct one. Fluorine, chlorine, bromine, iodine. So the chemical reactivity also decreases from top to bottom. Next, fourth one. Which halogen forms strongest oxyacids? So among that is option A fluorine, B chlorine, C bromine, D iodine. So the strongest oxyacid is HClO4, perchloric acid, which is formed by chlorine. The oxidant state in this case is +7. Next, fifth one. Which of the following is the weakest acid? In the case of hydrogen halides, HF, HCl, HBr, HI, the acidic strength increases from top to bottom. Acidic strength increases. So weakest acid is HF. Next, sixth one. Aqua regia is a mixture of. Aqua regia is a mixture of concentrated HCl and HNO3. Here given options are HCl and HNO3 are given. So they are in the ratio 3:1. HCl is 3, HNO3 is 1. So option A is the correct one. You have to read carefully the options. HCl, sometimes HNO3 is given first and HCl is given second. So HCl is always in 3 proportion and HNO3 is 1 ratio. So 3:1 ratio. HCl and HNO3 are in the ratio 3:1. Suppose if HNO3 is first given, HNO3 and HCl means 1:3 ratio. Okay. So option A is the correct one. Bleaching action of chlorine is due to. So this question is already discussed. Bleaching action of chlorine is mainly due to A. Oxidation, B. Reduction, C. Hydrolysis, D. Decomposition. It is mainly due to oxidation. This oxidation also occurs in presence of moisture. In presence of moisture, when this chlorine reacts with water, forming hydrochloric acid and hypochlorous acid. This hypochlorous acid releases nascent oxygen. HCl, HCl plus, wait 1 minute. HCl plus nascent oxygen. This nascent oxygen is responsible for the destruction of the color pigment. So, bleaching action of chlorine is due to oxidation. Next, 8th one. During the manufacture of chlorine by the electrolysis of brine, the byproducts are A H2, B NaOH, C NaOH and H2, D NaOH. D is NaOH. So we know this process is used for the manufacture of chlorine. Chlorine is produced at anode. Which is the positive electrode. At cathode, hydrogen and NaOH are produced. So these are the byproducts produced. So option C is the correct one. Okay, next. 9th one. What are the products obtained when excess of ammonia reacts with chlorine? Excess of ammonia reacts with chlorine. When excess of ammonia reacts with chlorine, forming ammonium chloride and nitrogen. When ammonia is taken in excess, forming ammonia chloride and nitrogen. So options given are N2 and NCl3. This NCl3 and HCl are formed when excess of chlorine is taken. This is also important. When ammonia is excess, ammonium chloride and N2 are formed. When chlorine is in excess, HCl and NCl3 are formed. This is the D answer. So here they are asking excess of ammonia. So N2 and ammonium chloride is the right answer. If the question is given like this, excess of chlorine reacts with ammonia, D is the correct one. Okay. Next, 10th one. The number of sigma and pi bonds in ClO4 minus. The structure is like this. Chlorine, O minus, double bond O, double bond O, double bond O. Here pi bonds are 1, 2, 3. 3 pi bonds. Sigma bonds are 1, 2, 3, 4. So 3 pi bonds and 4 sigma bonds. This option is present in C. So number of sigma and pi bonds in ClO4 minus ion is 4 sigma and 3 pi bonds. Next, 11th one. The hybridization of chlorine, this is spelling mistake, chlorine in ClF3 molecule. ClF3 molecule. Chlorine belongs to 7th group elements. So it contains 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. 3 fluorines form 3 sigma bonds with 3 electrons. So number of bond pair of electrons are 3. 3 bond pair of electrons plus lone pair of electrons, 2 lone pair of electrons. So total 5. 5 means which hybridization? Already I discussed in hybridization trick video, that is sp3 dehybridization. I have easily remembered that 5, 1s orbital, p is 3, d is 5. By totaling all these orbitals, we will get the total number. sp3d, s1, p3, d1. So total 5. So the hybridization in this case is sp3 dehybridization. sp3 dehybridization with the 2 lone pairs means the structure is T-shape. Okay. Next, 12th one. Among the oxyacids of chlorine, the strongest oxidizing agent is means reduction will takes place. That means it gains more electrons. Among the given compounds, maximum oxidation state is present in, that is +7 is present in A, that is perchloric acid. So it gains 7 electrons. So it can act as strong oxidizing agent. So perchloric acid is the strongest oxidizing agent. Next, the most abundant noble gas in the atmosphere. In the atmosphere, the most abundant noble gas is argon. Next, 14th one. Noble gases exist only in monoatomic state. Monoatomic state. This is due to, so noble gases are highly stable, completely filled electronic configuration. That means they are having lack of unpaired electrons. So option A, non-availability of unpaired electrons. High ionization energy is there for noble gas. Large size, zero electron affinity is there for noble gas. But the main reason is non-availability of unpaired electrons. Noble gases exist only in monoatomic state. The molecule with linear structure is, option A, XeF2, option B, XeO3, option C, XeF4, option D, XeF6. In XeF2, xenon belongs to inert gas. That means 8 valence electrons. So 2 bond pair of electrons plus 3 lone pair of electrons. Total 5. So hybridization is sp3d hybridization. sp3 dehybridization. Structure is linear. In the case of XeO3, xenon contains 8 valence electrons. Among 6 valence electrons, 3 oxygens form 3 pi bonds with 6 electrons. So 3 bond pair of electrons plus 1 lone pair of electron. Total 4. 4 means sp3 hybridization. 1 lone pair means trigonal pyramidal shape. XeF4, 4 bond pair of electrons plus 2 lone pair of electrons. So total 6. So hybridization is sp3d2. sp3d2 with 2 lone pairs means structure is square planar. In XeF6, 6 bond pair of electrons plus 1 lone pair of electron. So hybridization is sp3d3. 1 lone pair means distorted octahedral. So every time in EAPCET, JEE Mains and NEET exam, this type of question is asking about the structure or bond pair, lone pair. It is very important. So for this we have to verify the video of, that is hybridization trick video. It is very useful to you. Next, so the molecule with linear structure in the given options is XeF2. If you study all the 4 options, you will learn the more subject. Not the linear structure means XeF2. Don't stop here. So learn the what is the structure of B, C, D. Like this, if you learn the subject, it will be very useful to you. You will get the more marks in competitive or any other exams. Okay, next, XeF6. XeF6 on complete hydrolysis. XeF6 on complete hydrolysis gives XeO4, XeOF2, XeOF4, XeO3. So we know this XeF6 undergoes complete, that is hydrolysis, forming XeO3 plus HF. By balancing these 6 fluorines, so we have put 6. So hydrogens are 6, so we multiply this 3H2O. So it gives xenon trioxide. So option D is the correct one. Colored discharge tube for advertisement mainly contains xenon, helium, neon, argon. So generally for colored discharge tube, neon is used because it emits bright reddish orange light, which is the main seen in science. This is the main primary component. Okay, next, the gas used in thermometer is helium, oxygen, xenon, neon. Helium. So this helium is inert compound, low boiling point and non-reactive nature. It will get high accuracy value. Even at low temperatures, helium is used. Remaining inert gases are used, but at low temperatures, which is giving accurate measure means helium. Next, 19th one. The first stable compound of inert gas was prepared by Rayleigh and Ramsay, Bartlett, Franklin and Lockyer, Cavendish. So it was first prepared by Bartlett. So the first inert gas compound is XePTF6. So in some of the competitive examinations already asked the IUPAC nature of the first inert gas compound. So this is hexagenon hexafluoroplatinate. This is the first inert gas compound discovered by Bartlett in 1962. Next, law 20th one. Helium oxygen mixture is used by deep sea divers in preference to nitrogen oxygen mixture because option A, helium is much less soluble in blood than nitrogen. N2 is much less soluble in blood than helium. Due to high pressure, nitrogen reacts with oxygen to give poisonous nitric oxide. Nitrogen is highly soluble in water because helium is less soluble in blood. It prevents the risk of nitrogen narcosis and bends, that means pain in the tissues. More nitrogen gas dissolves in the blood. By using this helium, you can prevent the risk of, that is, nitrogen narcosis and bends.